All right, I'm going to pick up where Miss Harbaugh left off. Sorry I don't have as graceful of a voice as she does, but I'm going to do the best I can. So the first thing that we're going to go over is the sine and cosine functions on this unit circle. And what makes a unit circle special is that on a unit circle, the radius is always going to be 1. So at any point, you can see this circle that's around. Any time that you go from the center of the circle to a point on that circle, that is always going to be your radius, which is going to be 1 in our unit circle. And I'll get into the unit circle in just a minute. But what we want to do here is we want to break down this triangle that I've created at this specific position. Okay, and I know that this point on my unit circle is some x comma y point. Okay, and I can find out my x going from the center of my circle and seeing how I travel in the x direction. Okay, so that's how many units I traveled in the x, and then also how many units I travel in the y. And that gives me my x comma y point. So from this information, I can then write to the side over here, the information that I know about this triangle is that it's a 90 degrees triangle, and I can use my SOHCAHTOA then and figure out what those r, x, and y are if I had only bits and pieces of that triangle. So if I started with sine, so if I had sine of whatever theta is, and theta is here, whatever our reference angle is in this case. So sine theta I know is opposite over hypotenuse. But in this case, my opposite isn't just O, it's going to be in terms of x, y, or r. So opposite would then be so it would be opposite of my angle, so it would be my y value. And then my hypotenuse is always going to be r. Okay, so I'm going to go ahead and fill out this for cosine and tangent as well. All right, so now that I filled those out, you can see, and I color-coded them as well, so you can see that these are the general ratios for my unit circle triangle that I can create. So something that I notice now is that since I know that my radius is 1, I can then look at anything that has an r in my ratio, and then I notice that sine theta is going to equal y over r, but I know that r is just 1, right? So therefore, my sine theta should just equal y. So I'm just going to write that up above. So I know that sine theta is equal to y. And then I can look at the same thing with cosine, where cosine is just going to equal whatever my x value is divided by 1. So cosine theta ultimately just equals x. So same thing, cosine theta is equal to x. So now if I look at my point that I'm given, my x and y point, I can then label my x comma y as cosine theta comma sine theta, because that's the same thing as x comma y. I can also then look at my tangent of theta, and my tangent of theta I can then write in terms of cosine theta and sine theta. So I know that since this is y divided by x, that then I know that this is going to be sine, because that's my y, divided by cosine. So I'm going to go ahead and write that as well. So tangent is also, oops, that is not how you spell it. So I'd have tangent of theta is equal to my y, which again is sine, over my cosine of theta. And I remember which one is x and y based on alphabetical order, right? So it's x comma y, so x comes before y, and c comes before s. So x comma y, and then cosine and sine, so those are also in alphabetical order. So if I'm going down to this other circle that I have drawn here, I know then that depending on which quadrant I'm at will tell me what's positive and what's negative. So we have our first point, which is just my x comma y, and then my second point is when my x is negative, but my y is still positive. Third point, I have a negative x and a negative y. And in my fourth quadrant, I have a positive x and a negative y. So let's answer this question that's below. Why learn reference angles? Well, reference angles are going to help, especially when you want to try to create these triangles, because they are always going to go from the terminal ray, so if this was my terminal ray, down to my x-axis, right? So this is my x-axis. This is the distance in an angle that I've traveled from my terminal ray to my x-axis. So that's theta. Same thing here. If this was my terminal ray, I drop to the x-axis. That's another theta. Again, here's another terminal ray. I drop to my, so in this case, I guess I don't drop, I go up to my x-axis. That's a theta. And then from this one, same thing. That's my theta. So reference angles help me to identify what the angle is that's in my triangle, depending on which quadrant I am in. All right. So here's a unit circle, and again, that means that we have a radius of 1. And I'm going to say that all of these reference angles, so dropping from these terminal rays to my x-axis, these thetas are all going to equal 45 degrees. I then am going to create a triangle by dropping a line from a point on my circle down to the x-axis, so then I can create this triangle that we just talked about in the last slide. And I know that it's a right triangle, and I also know that my radius is 1, so I'm going to write that 1 in here. So if I know that I have a 45-degree angle, I know quite a bit of information about a 45-90 triangle. I know that this is going to be my hypotenuse, and I know that these two side lengths should be equal to one another. And if you guys remember from special right triangles, it should be x, this should be x, and this is x root 2. So I just wrote in x, x, and x root 2 on my triangle, and I know that this has to equal 1 since my radius always has to equal 1. Therefore, I can just do a quick little solving, and I know that x would then have to equal 1 over root 2. Or if I rationalize that, that would be root 2 over 2, if I wanted to rationalize the denominator. So I know that my radius is 1, and I know that this is my x value. So then I can go ahead and just write in that x is equal to root 2 over 2, and x is equal to root 2 over 2. So therefore, my point that I have at this location on my unit circle would be a point of root 2 over 2, comma, root 2 over 2. Okay? And I know that information, and I know that this will actually be the exact same as this point that I would have over here, but what's the only thing that will be different? The x will be negative, and my y will still be positive. So then I'm going to have my negative root 2 over 2 and root 2 over 2. Okay? And then, of course, I can fill those in then for any other location with a reference angle of also 45 degrees, which I'll fill out in just a second. So I went ahead and just went to go fill those in. Sorry, I got a little bit aggressive on this one, got pretty big. But then this question asks, simplify the trig ratios for sine of x and cosine of x. What does this mean? So we already did that actually in the last slide when we simplified cosine of x to just be x and sine of x to be y. So that x comma y point being the same thing as your x comma y coordinate point. So now, using the ratios that we just talked about in the other two slides, I want you to try to do these three problems, okay? So finding the exact value of this, but I want you to do this without your calculator. You should be able to look at sine of 180 degrees and give me the value that that equals without plugging it into your TI. So I'll do sine of 180 just for practice, and then you guys can do these on your own. So sine of 180 degrees. So if I started at my initial ray, which is right here again, and I go 180 degrees and I go counterclockwise, so I'm at right here, okay, and I am at this location because I'm on the unit circle where my radius is 1, okay. This point that I'm at is my x comma y point, which is negative 1 comma 0, and I know that based on what I was talking about earlier, that this is cosine theta, comma, sine theta. So I know then that my sine theta, so my sine of 180 degrees, will equal to 0. So go ahead and pause the video real quick and just give a guess for cosine of 0 and tangent of 270, and then I'll write the answers in just a second and you can check them. So pause the video right now. All right, so hopefully you at least got cosine of 0 degrees to be 0, because that's at 0, 0, so your x is your cosine theta, so you got 0. And then this was a unique situation, right? 270 degrees, I started at 0, went 270. I was at 0, -1 as the coordinate point, and I know that tangent, whoops, that was supposed to have a theta in it. So tangent theta would equal y over x. And when I plug those in, I got -1 over 0, but you can't divide by 0, right? So anytime that you get into this situation, then you have a trig function that is undefined. It is not possible for you to divide by that 0, so tangent of 270 is just undefined. All right, so something that you'll see probably in your textbook homework and what you'll see on future homework quizzes are questions similar to this. And before I go over these two questions, something that you probably remember from Algebra 2 that I didn't go over in my last few slides is that when we're looking at our 4 quadrants that we have and we're looking at the trig ratios, we can just remember that all students take calculus. Okay, and if you remember this from Algebra 2, what this means is that in the first quadrant, all functions are positive here. So sine, cosine, and tangent will all be positive here. Okay, in this quadrant, only sine is positive. Cosine and tangent will be negative. Here, only tangent will be positive. Sine and cosine will be negative. And then in the fourth quadrant, only cosine will be positive. Sine and tangent will be negative. Okay, so just remember that as we're going through. All right, so then if we're looking at this first question, it says to find all 3 of my ratios without a TI in spire of the terminal ray that passes through 3 and -5. So if I'm going to graph that, I know that that's going to be my fourth quadrant. So 1, 2, 3, 2, 3, 4, 5. Okay, so that's going to be my terminal ray and it passes through that place. Okay, so if I wanted to find out what my trig functions are, I'm going to drop, or I guess bring up, my other part of my triangle, so then I can create my 90-degree triangle, right? And then I know my x value is that 3, and this is my -5, okay? And then I have my hypotenuse. So how can I find my hypotenuse? I know that then I can just use Pythagorean theorem to find that, which will be the square root of 34. Okay, so then I can come up with all of my different trig functions. So sine of that would equal... Okay, so go ahead and pause the video and try these guys out and see if you come up with the same ratios that I do. So go ahead and pause. All right, so you can check your answers with mine, and just be aware that I rationalized here. You don't have to do that, but ideally you should be able to identify that these two are at least equal to one another. So if you saw this as an answer, as a multiple choice, you'd be able to see it. So with this, some of you might be wondering, well, okay, well, sine theta, I thought that you said in the last slide that it was y. It's only equal to y when it's on a unit circle. And since my radius in this case is not 1, which is in our unit circle, it's the square root of 34, it's not going to just be my y and my x value. That's not the case. That's only with unit circles. So just keep that in mind, okay? So I did actually have to look. I had to look from my theta. I had to look at my opposite and then compare it to my hypotenuse, and that's how I got those ratios. Okay, another question that you might encounter is to find all angles. So this notation just means any angle between 0 degrees and 360 degrees that make tangent theta equal to this value. Okay, so this is some simplified ratio, but I'm not going to sit here and try to figure out what that y divided by x is. This is a type of question that you would be able to use your TI in Spire. Okay, so if I use my TI in Spire, I am going to have to plug in the inverse of tangent, so tan to the -1 of 0.18726. And that's going to give me my theta. And what theta equals ultimately is 10 point, so I'm going to round it to 10.6 degrees, okay? So make sure that you are in degrees when you're doing this. We'll talk about radians actually later this unit, but right now you're going to be in degrees. So that's 10.6 degrees, okay? So now what I want to check is where tangent is positive, okay? So I know that it's positive because the ratio that was just given to me is a positive value, right? So where is tangent positive? Well, I definitely know it's in the first quadrant, but it's also in the third quadrant, okay? So what I'm going to do then is I'm just going to come up with my two terminal rays of those two different scenarios because there's two places where that could be true. And this value that I got for my angle actually will be my reference angle. So 10.6 degrees, and this will also be 10.6 degrees, right? So one of my answers is going to be 10.6 degrees. That makes that true because that's the one that's in the first quadrant, right? But how am I going to find the one that's in the third quadrant? Well, easy enough. If I start all my angle measurements from my initial ray here, I'm going to go around 90, 180, and then 180 plus that 10.6. Right, so that's going to give me 190.6 degrees would be my other answer that would make that true. So I found all my angles, and there's two of them. This is my first answer, and this is my second answer that makes this value true. And just going back to the other problem that we started with up here, I just to check my work, right? So I was in the fourth quadrant. The only thing that should be positive, the only ratio that should be positive was that cosine. And if I look at these, that's true. Cosine was the only one that was positive. My sine was negative and my tangent was negative. So that's just a really good way to double check if you're getting the right ratios or if you have your negatives messed up or in a wrong place.